Hello, welcome. Thank you for having us here. What we're here to discuss is an early developed technology regarding 12 gauge reactive breaching. We think this is a game changer as far as inert breaching, and in comparison, this opens up a lot of doors, so to speak. Our company, Energetic Materials and Products, we are a small company out of Texas. Some of what we do is the breaching on the left there with regards to ballistics, but also we have a product that we've shown here before, the Tech Torch, is thermal breaching. It's also used in some EOD and counter IED applications. And then we have some other ballistic projects and true explosive projects with selectable fragmentation, directional energy, and some examples of the structural reactive materials over here. What our company really is poised for is going from concept, early concept, through some prototype development all the way to some test and evaluation. We don't normally do, or we're not set up for large production, and that's where we partner with other industry members. On this innovation, what we're discussing is a reactive 12 gauge. We have developed this to work with standard ammunition or standard weapons and standard tactics that 12 gauge breachers use currently. Basically, the way it works and what makes this different is it is a frangible round that is designed to enter the door or the structure and react on impact inside the structure. As the gas expands, you get more energy and more destruction to the door or target. This creates a lot of great things for the users. There's some high-speed video down there at the bottom of the slug coming into a hollow door. Typically, the steel doors take several shots for existing breachers. And with this reactive technology, it takes sometimes a single shot to get in through a door and cause significantly more damage. You can see in that image there how the reaction is expanding. That's a partial door just for cost savings, but you can see the gas and the flame coming out. And it is designed to still be safe for the operator. So the slug itself is frangible. The operator can stand close, and even the hazards behind the door are pretty minimal with the bullet breaking up on impact. Some other examples, if this video plays, yeah. So this is a heavy steel door that we did testing with DSTL some time ago. And you can see one shot with that heavy door and the breaching round entered quite easily. You can see the door expanded, which that wouldn't typically happen on an inert round. On an inert round, you get damage just around the impact zone. And there's a still picture there of the door damage. And obviously there was 2 bolts going into the frame that were sheared off during that expansion and that reaction. Some other doors, steel doors are great examples for this technology and where this technology shines compared to conventional inerts. Wood doors, we've tested against several types. Right in the center is more like a hotel door, heavy wood door, and it does work against that much better. Sometimes it does take multiple shots because you're removing a lot more mass in the heavy wood doors. As far as the lighter weight wood doors, I'm not talking about totally hollow, but particle board construction, it is much more effective than the inert rounds as well. I've seen some of the particle wood doors where it takes 2 to 3 shots for the hinge plate. You can see on that image down there on the right, 1 shot, and the hinge was actually ejected from the door and laying on the ground after the shot. One other thing that is unique about this round is with standard conventional inerts, they do a 4-inch or less standoff. This round is designed to give you some stand back, and now you can be a little less accurate. Because of that chemical reaction, you don't have to hit the sweet spot as good. And then with our flight stability that we've worked out, when you hit that door, you can be further off and do the same damage. And you can see a little bit standoff there. That's probably a 2 or 3 meter standoff. And that obviously helps the warfighter stay out of the danger zone in some instances. With DSTL, we also pursued shooting this against armored vehicles, and these were kind of homemade armored vehicles with a 1/4-inch steel plate on the inside. But again, a surprise to us, with 1 shot we could get into these vehicle doors. Some of this testing involved putting mannequins with pressure sensors inside the vehicle and outside the vehicle, showing below lethal pressure levels. The armor plate actually does a great job of protecting any kind of debris or pressure getting into the vehicle. And in all these tests, with the projectile hitting right next to the lock mechanism, we didn't break the windows, things like that. So that shows you how low lethality it was. But with that reaction happening inside the door again, it was unique that you create a pressurization event that throws the door out open after the shot. What we've done so far, again, this is early development, early feasibility. We have tested it for about 9 to 12 months, done some feasibility demonstrations with the operators and in our own labs for production means, for LRIP means. We have teamed with Orbital ATK. They have some patents on reactive material and ballistics. We have patented this as well, that we're working together on that patent portfolio. CSI is currently in partnership with us for the tech torch manufacturing, and they have inert breaching rounds already. They are definitely interested in mass producing this for users and talking with us about what's required for that. As far as our needs going forward, we still do need some safety testing and manufacturing consistency testing, and we are looking for funding. We have a DOTC white paper that has been accepted that can be funded today.